Good day, this is Professor Wills, drwillphd, PhD, and today is Tuesday, January 11, 2022. It is 2:05 and 14 seconds, a.m. Eastern Standard Time. Today's research, cancer therapy. So let's hop to it here. Cancer therapy using on-site synthesis of anti-cancer drugs. Date January 10th, 2022. Source, Riken. The researchers have successfully treated cancer in mice using metal catalysts that assemble anti-cancer drugs together inside the body. And this study is the first to report of therapeutic in vivo synthetic chemistry being used to make anti-cancer substances where they are needed, simply by injecting their ingredients through a vein. Because this technique avoids indiscriminate tissue damage, it is expected to have a significant impact on cancer treatment. Aside from effectiveness at killing cancer cells, a major challenge to cancer chemotherapy is how to mitigate the toxic side effects on the body. The drugs that can damage cancer cells can damage non-cancerous cells as well, and the negative side effects of chemotherapy can cause permanent and debilitating damage. The current methods for reducing these side effects include selective delivery of anti-cancer drugs to cancer tissue, drug delivery, and conversion of non-toxic compounds, prodrugs, into toxic compounds nearby the cancerous tissue. A new study has developed a method for activating prodrugs using transition metal catalysts inside the body. When the catalyst is injected into an organism, it usually has no effect because it is destroyed by antioxidants such as glutathione. By placing the transition metal catalyst inside special pockets within a protein, the researchers have been able to avoid this problem and stabilize the catalytic function in vivo, thus ensuring that the chemical reaction can proceed efficiently in the body. And for this technique to work, the catalyst needs to selectively find its way to the cancer. As in their previous studies, the team targeted the catalyst to the cancer by attaching chains of cancer-binding sugar molecules to the surface of the carrier protein. And using these techniques, the group succeeded in inhibiting cancer growth and metastasis, as well as reducing the side effects. The new study is a proof of concept in which cancer in mice was treated by actually assembling anti-cancer drugs inside the body near the cancer cells. In the past, researchers used similar methods to attach anti-cancer drugs to tumors, but here, researchers were able to avoid putting any toxic drugs into the body at all. Noting that the basic skeleton of most anti-cancer drugs contains a benzene ring, the researchers started by making benzene rings inside the body using transition metal catalysts. No one believed that artificially synthesizing benzene rings inside the body was possible, but researchers were confident that they can do it based on their previous achievements. And using a transition metal catalyzed complex designed for selective delivery to cancerous tissues, they succeeded in efficiently creating the benzene rings needed by cancer drugs in the vicinity of cancer cells. By using non-toxic substances and only joining them together to form active anti-cancer drugs at the tumor site, they saw a 1,000 times increase in the cancer-inhibiting activity of the cancer drugs. And simply administering the ingredients needed for the drug, along with a transition metal catalyst, through a vein, cancer growth was inhibited without side effects, such as weight loss. And this is the first time that active anti-cancer drugs have been assembled on-site and effectively combated cancer by simply injecting the ingredients for the drug through a vein. In addition to benzene, the methodology developed in this study is expected to enable a variety of other molecules to be synthesized inside the body. The hope is that this type of chemotherapy will become a useful therapeutic platform for the future of cancer treatment. Many patients with cancer are dying because of the side effects of cancer treatment. Researchers believe that their technology, which attacks cancer cells highly effectively, without side effects, will be able to save lives. The method will also allow researchers to reconsider using compounds that have not been used before because they were too toxic when delivered to the whole body, and how they can be synthesized at the tumor site without affecting healthy tissue. Researchers believe this is a paradigm shift for pharmaceuticals and drug discovery. Good day, this is Professor Will, CBMD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.